I want to give some context around the role that the Tuva ecosystem of products plays in the space. The products that we're building are all the key ingredients to build a healthcare data platform. And by healthcare data platform, what we mean is this big machine that takes raw claims or clinical data as an input and it spits out analytics insights as an output. We basically want to answer questions that we care about. Examples of questions that we care about are things like, what is our spend for type 2 diabetes? What does our ED utilization look like? What is our readmission rate for COPD? These are just a couple examples, but we can easily imagine an endless list of such questions that organizations want to answer with their data. And the reason why it's so difficult to answer questions like this with raw healthcare data is because the raw data doesn't have the concepts in it that can help us do analysis. So for instance, there is no statement in your raw data that says the readmission rate for COPD is 8.2%. In fact, what your raw data looks like is more like this. It's just a bunch of bills with all these cryptic looking healthcare specific codes like bill type code or revenue center code or admit type code or admit source code, etc. So it looks nothing like the kinds of questions we want to answer. For instance, raw claims data has no concept of an acute inpatient claim or of an ED encounter or of an office visit. And in order to answer even the most basic questions, we need to define concepts on top of the raw data, and we need a whole universe of these concepts. So having a couple dozen concepts actually gets you nowhere in terms of being able to do analysis. And in order to be productive doing analytics, you need more like thousands of concepts defined on top of your raw data. So that's one challenge. Another challenge is that the questions that we typically ask are not very precise. So if you take an innocent looking question like, what is our spend for type 2 diabetes? You need to define a whole collection of concepts just to get specific enough about what you mean with this question so that you can write a query against your data to answer it. So to start with, are we talking about medical spend, pharmacy spend, total spend? How do you even define if somebody has type 2 diabetes? Do you look for the presence of certain diagnosis codes? If so, which ones? Do you look for the presence of certain medications being taken? If so, what are the drug codes corresponding to those medications? Are we talking about the total cost of care for patients with type 2 diabetes, including things like them breaking their arm, for example? Or are we talking about only diabetes-related spend? And if so, how do you define diabetes-related spend in raw data? So you get a flavor for how much specificity you need to have in order to just ask a very simple question. So we have these two problems, the problem that raw data is raw and has no concepts in it, and the problem that we need to make our questions precise to do any kind of analysis. And the solution to both of these problems is the same. The solution is we need to define concepts using the raw data. So we need to define concepts that make the data usable for answering questions, like for example, the concept of an ED encounter or the concept of a patient with type 2 diabetes. And we need to define concepts that make our thinking and therefore our questions precise, like for example, the concept of what we mean when we say the total spend for condition X. So the solution to our problems is defining concepts using raw data. And there's challenges to doing this. First of all, like I said, we need a whole universe of concepts to be productive doing analytics. We need thousands of concepts so that we can do analysis. These concepts also need to be defined very precisely in code. This is typically done by people who write code. And it is an insane amount of work to translate all these nuanced healthcare definitions into code with no mistakes precisely and building all that code base and then maintaining that over time with changing code sets and changing definitions and changing logic. And these are very nuanced concepts that require deep knowledge of healthcare data, of how medicine is practiced, of how medical services are billed. This kind of knowledge is very difficult to come by. In fact, it mostly just lives in the heads of very specialized individuals who unfortunately are usually not the same people as the people who write code. So let's look at this challenge in a little more detail. When you have multiple healthcare data sources that you're ingesting into a data platform, all of these raw data sources come in different formats. They all have different data models. They all have different field names. They all have different grain. They have different data quality problems. And in order to do analysis on your combined data sources, you need a common data model to put all your data in the same format so you can be comparing it in an apples to apples way. Once all your data sources can be in the same common data model, you can union them and you can do analysis in the combined data set. But even if you successfully do that, you still only have raw data. And like we said, to answer even the most basic analytics questions, we need a whole universe of high-level concepts defined on top of the raw data. Once you have all your data sources in a common data model, in order to start doing analysis, at the very least, you're going to need to have a service category grouper, an encounter grouper, an episode grouper. These ideas pre-process your raw claims into useful concepts that are going to be used in every downstream analysis. You also need to extract all the common atomic building blocks, like the concept of a patient or the concept of an encounter or the concept of a condition or the concept of a procedure. These kinds of concepts are basic atomic concepts that also do not exist in the raw data. They need to be defined with some logic, and they are the core concepts that are common building blocks for all downstream analytics as well. And then on top of all of this, you need to define more sophisticated, higher level concepts that can be used for different kinds of analyses. For example, you could define a chronic condition smart, where all the logic to identify which patients have which chronic conditions is going to be housed. And that shows what diagnosis codes or what medications are relevant with all the corresponding codes to identify chronic conditions being present in different patients. Similarly, for doing financial analytics, you want to define a data mart where all the concepts related to healthcare finance are going to be housed. Similarly, for readmission analytics, you might want to define a mart with all the concepts relevant for doing readmission analytics, or for doing emergency department analytics, or for doing HCCs or HCC suspecting, etc. So you need to define a whole universe of data marts with high-level concepts that are frequently used in many analyses. So these are just examples that give a flavor of how large the universe of concepts to build is. And these are not anyone's secret sauce analyses. These are just table stakes that we all need to just start doing analytics. And for years, we have all been reinventing the wheel, redefining these concepts in complete isolation inside the walled gardens of our own companies. And we're all introducing slight differences into our definitions, potentially introducing bugs into our definitions. As an industry, we're not getting better at this because everybody's just starting from scratch, doing the same thing over and over in slightly different ways. So this was the main motivation to start the Tuva project. When we started Tuva, our fundamental idea was that if we could define a common data model to model raw healthcare data in, we could then build a Tuva package that ran on top of this common data model, and it could, out of the box, produce this universe of data marts with all these concepts defined in a very coherent way for the whole industry to use. And so this common data model that we defined to model raw healthcare data, together with the data model that is produced out of the box, where all these different data marts are organizing concepts and ideas for analyses, both of these things became what is the Tuva data model. And the Tuva package is an open source project that we built that runs on all major cloud data warehouses. So over time, the universe of Tuva data marts has kept us expanding and being polished. This is basically what the entire focus of our team has been for the last few years. And we've also gotten feedback about how expensive it is to run compute in cloud data warehouses at scale. So we built Tuva Enterprise to run in a container outside of the data warehouse, and that's 90% cheaper compute cost than running that inside of the data warehouse. But over time, the Tuva project grew into something larger than the Tuva data model. Now the Tuva project is this large universe of open source tools needed to build a healthcare data platform, and going from raw healthcare data sources into analytics insights. So the Tuva data model is still the heart and soul of the Tuva project, and all other tools in the Tuva project are designed to work in harmony with the Tuva data model. So for instance, we have Tuva EMPI. This is a standalone patient matching application. It's designed to work with the Tuva ecosystem to create universal person IDs and propagate them to the analytics layer. But this can be used independently of the rest of the Tuva ecosystem. It's a standalone software application. In fact, there are examples of companies that use Tuva EMPI before adopting any other tools in the Tuva project. They just use the application by itself. Similarly, with terminology sets, this is a collection of commonly used healthcare terminologies like ICD, DRG, LOINC, etc. These terminologies are maintained by different organizations. They're updated at different frequencies. They're scattered all over the internet. It is a very large amount of work to compile these terminologies, maintain them up to date, and have them ready for analysis inside of your data platform. But with Tuva, we make it easy and possible to just deploy all these terminologies, have the latest version of all of them in a push button kind of way and have them in your data platform. This can be used independently of the rest of the Tuva ecosystem. And like for EMPI, there are examples of organizations that have adopted Tuva terminology without necessarily adopting other tools in the Tuva project. There's other tools in the Tuva project like data quality testing or analytics dashboards and notebooks or predictive models. These tools are different because these are tools that run on top of the Tuva data model. And it is a prerequisite to have your data in the Tuva data model to run these tools because these tools rely on concepts that are defined in the Tuva data model. So that's a summary of what the Tuva project comprises, and you can read all the documentation about it in the tuvaproject.com.